Hello students, today I will teach you the compounds of nitrogen family. First compound, that is dinitrogen. Dinitrogen is commercially produced by liquefaction and fractional distillation of air. And this liquid dinitrogen, it distills out, first leaving behind liquid oxygen. And the laboratory preparation of dinitrogen, it can be prepared by treating an aqueous solution of ammonium chloride with sodium nitrite. The reaction is that ammonium chloride plus sodium nitrite, it gives nitrogen gas. And during this reaction, a small amount of NO and HNO3 are also formed. So these impurities can be removed by passing the gas through aqueous solution of sulfuric acid, which contains potassium dichromate. The next preparation of dinitrogen is the thermal decomposition of ammonium dichromate. So on heating ammonium dichromate, it gives nitrogen gas. These are the preparation of dinitrogen, and pure nitrogen can also be obtained by the thermal decomposition of sodium azide or barium azide. It can also be prepared by thermal decomposition of sodium azide or barium azide. Now the physical properties of dinitrogen. Dinitrogen, it is colorless, odorless, tasteless gas, and it is non-toxic in nature. And it has low molar mass and low intermolecular forces. And it has mainly two stable isotopes, that is nitrogen 14 and nitrogen 15, and it has very low solubility in water, and also it has low freezing point and boiling point. And this dinitrogen, it is rather inert at room temperature because it's having high bond enthalpy of nitrogen-nitrogen bond. But the reactivity can be increased by increasing the temperature, and at higher temperature it directly combines with some metals and form the ionic nitrides, and it can also react with non-metals, and when it reacts with non-metals it forms covalent nitrides. So we can see the properties. When nitrogen reacts with metals, it forms ionic nitride. This ionic nitride is formed, such as when it reacts with the lithium metal, it forms lithium nitride. And when it reacts with the hydrogen, it forms ammonia. So these are the reactions of nitrogen with metals, lithium, and with hydrogen. And it can also react with oxygen. When it reacts with oxygen, it forms its oxide, that is NO. So reaction of this nitrogen with metals and non-metals. So when it reacts with the metal, it forms nitrides, and when it reacts with non-metals, it forms covalent nitrides. And there are main uses of nitrogen. There are some uses of the nitrogen. Nitrogen can be used in the manufacture of ammonia. And another use of the nitrogen, it provides an inert atmosphere in industries, and it is also used as a refrigerant. And liquid nitrogen, that is used in refrigerant to preserve the biological materials, food items, etc. So these are the various uses of the dinitrogen. The next compound of the nitrogen family, that is the ammonia. So preparation of the ammonia. Ammonia can be prepared in small quantities. First preparation of the ammonia, that is Haber's process. So on large scale, this ammonia can be prepared by Haber's process by the reaction of nitrogen and hydrogen. It gives the ammonia gas. And it can also be prepared from ammonium salts. So from the ammonium salt, it can be prepared on a small scale. So ammonium salts which decompose when treated with caustic soda or lime. But this ammonium chloride, it reacts with the calcium hydroxide. It gives calcium chloride and ammonia. So it can be prepared on large scale as well as on small scale. So that is the process of Haber's process, and it is the method of preparation from the ammonium salt. Now the physical properties of the ammonia. So ammonia can be prepared. So ammonia having the following properties. It is colorless and having pungent odor. And the hydrogen bonding, does it have higher boiling point and melting point, because in ammonia it's having the hydrogen bonding. So due to which it associated and it's from the higher melting point and boiling point. And in solid as well as in liquid state, it is associated, due to its having higher melting and boiling point. And this ammonia molecule is trigonal pyramidal structure. And it has 3 bond pairs and 1 lone pair. Now, the chemical properties of dinitrogen. Chemical properties of dinitrogen. First is the solubility of nitrogen with water. So nitrogen is highly soluble in water, and its aqueous solution is weakly basic because it forms hydrogen ions, hydroxyl ions, because it forms hydroxyl ions, OH ions. So the reaction, ammonia reacts with water, it forms weakly base, that is ammonium hydroxide. Next property, reaction with acid. So when ammonia, it can react with acid because ammonia, it's having the lone pair of electron, so it is Lewis base. Nature of ammonia, that is Lewis base. So when it reacts with acids, like it forms ammonium salts with acids. Example, ammonium chloride, ammonium sulfate, etc. As it is a weak base. And it precipitates the hydroxides of many materials from their salt solution. For example, ferric chloride reacts with the aqueous solution of ammonium hydroxide. It gives this product. So when it reacts with the acid, it forms the salt. So it's showing that ammonia is basic in nature. Nature of ammonia is basic. Then the uses of ammonia. Ammonia uses in production of various nitrogenous fertilizers such as ammonium nitrate, urea, ammonium phosphate, ammonium sulfate, etc. And it is also used in the manufacture of inorganic nitrogen compounds. The most important compound, nitric acid. And the liquid ammonia is also used as refrigerant. It is used as an refrigerant. Now the oxides of ammonia. Oxides of ammonia. Ammonia, oxides of nitrogen, oxides of nitrogen. So nitrogen, it's having number 1 nitrous oxide, which having oxidation state +1, and this nitrous oxide, that is colorless and it is neutral. Nitrous oxide is colorless and neutral. And the second oxide of nitrogen, that is nitric oxide. So this nitric oxide, it's having oxidation state +2, and it is also colorless and neutral. And the next oxide of the nitrogen, that is nitrogen trioxide. So this nitrogen trioxide, it's having +3 oxidation state, and the physical appearance of this nitrogen trioxide, it is blue solid and acidic. Next oxide of the nitrogen, that is nitrogen dioxide. This nitrogen dioxide, it's having +4 oxidation state, and it is also colorless solid or liquid, and it is acidic in nature. Next oxide of the nitrogen, that is dinitrogen pentoxide. It's having +5 oxidation state, and it is also colorless and acidic in nature. So these are the 5 oxides of the nitrogen: N2O, NO, N2O3, NO2, N2O4 and N2O5. Nitrogen dioxide and nitrogen tetroxide. So these are the oxides of the nitrogen. Now we can see the Lewis dot main resonance structure of these oxides of the nitrogen. First is the dinitrogen. Second one, that is NO and N2O5, N2O4 and N2O3, dinitrogen trioxide. These are the Lewis dot structure, the main resonance structure of the oxide of nitrogen. The NO2 structure, why does the question arises that NO2 it dimerizes? NO2 that dimerizes because NO2 that contains odd number of valence electron. So it behaves as a typical odd molecule. So on dimerization, it converts into N2O4. That is N2O4. So due to which NO2 it dimerizes, because in NO2 structure it's having only odd number of valence electron. So that is the Lewis dot structure of main resonating structure. And next question arises, why Does the ammonia act as Lewis base? What is the reason behind that ammonia act as the Lewis base? So answer is that in the structure of ammonia, nitrogen atom, it has one lone pair of electrons which is available for donation. So the species which can donate lone pair of electrons act as Lewis base. So due to which ammonia act as Lewis base due to presence of lone pair of electron.